What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be doing in this video is looking a little bit into the financial planning portfolio project. In this video, what I'm going to cover is how to do a few steps of the portfolio project for you in a hopes that this can help you complete some of this on your own. So an overview of the project is we have Serena and Juan. They're making investments and they want to pick different scenarios that they should invest in. We're looking at 5 different options here. We're looking at simple interest, just simple, get your interest annually at the end of the year, compounded monthly, compounded daily, a CD account where the interest is gained after a certain number of weeks, and a continuous interest-bearing account. First thing you do when you get this project is go File, Make a Copy. When you make a copy, make sure you give it a nice name, like whatever your name is. So maybe like my name is Mr. R, right? And I write whatever period I'm in. But I want to make sure that I save the project with a name. Always do this when you copy a document and get started. Once this loads up, first thing you're going to do is assign some variables, some values, right? So I have all these variables here, A, B, C, D, E, F, G, H. And for each of these variables, what you want to do is assign some value and you pick from the list. So for A, you can pick the number 1, 2, or 3. For me, I'm going to pick maybe, I don't know, I'll pick 1. So I can just delete the rest of these. And my variable for A is 1. Then for B, I'm going to pick a variable, I don't know, 4. For C, I need to pick a variable. Well, I already picked 4, so maybe here I'll pick 2. For D, I need to pick a variable. Maybe here I pick 9. For E, I need to pick a variable. Maybe I pick 7. Boom. And for F, maybe I'll pick 5. I didn't pick one yet that has a 5. For G, I'm going to pick 25 because I just like that number. And for H, maybe I'll pick, I don't know, 750. So you got to pick a variable for each. That's step 0, we'll say. It's not really, it's a necessity for the project, but it's not also like, you're not really doing anything. Great, we picked exactly one variable for each number. In part 2, you're going to build the functions, and I was nice enough to go through here and write the general forms of the functions. And again, it's an annual interest compounded monthly, compounded daily, an account where the interest is gained after E weeks, and finally that continuous interest-bearing account. So let's build the one for A of T, the simple annual interest. And when you do this on your own, please don't pick the same numbers I picked. Please don't do that, because then we're going to have the same work. It's like you're going to just be handing in the YouTube video. It's not going to be very fun for me to read, and it's not going to be great for you to complete. So here it says create a function A of T where it earns H dollars and grows by E.C% every 2 T years. So I'm just going to go down here and just kind of copy down what H is. I can see for me, H was 750. So I would go boom, 750, and grows by E.C%. E.C is 7.2% annually. It's a pretty good rate, 7.2%. Beautiful thing. So that's kind of what this was for me when I did this, if you look. Beautiful thing. And now I just want to write the formula. So here, I don't know what the time is. It hasn't been specified, but I know what my principal is. My principal here is 750. My rate here is 7.2%, but of course you want to write that as a decimal. So either divide 7.2 by 100, which translates to moving the decimal 2 places to the right. You get this here. Beautiful thing. Here I have another one, and for this one here, it's H, but it grows by E point B. Well, I know E was 7, so I just have to change that one to a B. Let's see what I had for B. B here was 4. Okay, not too shabby, so 7.4%. And then I do the same thing. My principal is going to be 750 still, because that's what I picked. My rate here is going to be 7.4%. which again I need to write as a decimal. Maybe I'll do a little quick zoom here for y'all. Here's a quick zoom so you can see this a little bit better. Boom, I'm right here, 7.4%, but of course that needs to be as a decimal, which means divide by 100 is what percent means. So if I divide this by 100, it moves the decimal 2 places to the right, something like that, and it's done. Beautiful thing, beautiful thing. That's part one. You're creating those 5 functions. I did the first 2 with you. I think you'll be able to do the next 3. Moving on to part 2, what you have to do is find what is the annual interest rate for each of these functions. Well, guess what? The first one already has annual interest rate. So what I'm going to do for the first one is I'm just going to copy my function a of t, which is a beautiful thing like this. A of t, here's my function for annual. And we know the annual interest rate because it already is an annual interest rate function, nothing to do there. That's just 7.2% annual interest. No big deal. Now, one of the ideas behind any type of exponential function is we want to convert them all into annual interest, because if you convert them all into annual interest, you can start to compare them and see which ones have the best rate. Well, in order to convert things into simple annual interest, what you have to do is isolate the exponent of time by itself. There can be nothing else there. So I'm going to do the monthly one as an example. And here I could see that I'm getting on this function here, I'm going to get 7.4%, but I'm getting that money annually, but that rate is being compounded monthly. So it's actually going to end up being more than 7.4% because I'm getting a 12th of that 7.4%, 12 times a year. So it ends up being a lot more. So what I want to do here is I just want to get this t isolated, so get it isolated by itself. And there's only a couple steps to do that. The first step to do that is just to figure out what the base is. I'm going to use a graphing calculator, but you could also just go to Google and type in calculator and do this same thing. So I'm going to do one, and maybe I'll use Google too. Later, there we go, boom, and I'll just use the calculator, why not? So what's nice about using this is I might be able to copy and paste. So I'm going to do 1 plus 0.74, 0.74 divided by 12, enter, and I get this. And what's nice is, you can just copy and paste that right here. Boom. Now all I need to do is bring that 12 to the inside to isolate the exponential function, or isolate the exponent in the exponential function. Great. So right now, once I move that 12 inside, to do this, I go edit or insert equation. I want that equation toolbar. So what I'm going to do is I'm going to be a little fancy. I'm going to go insert equation. And now I have the equation toolbar open right here. You see that? So I can go back here and add that exponent by hitting this one, math operation, and the x to the b. I press the right on my directional pad and I can move the 12 inside. A little tricky, but again, you click here and do the 12. Not the best in Google. They've done better things, but it is what it is. Right now it's in annual interest rate form, but I kind of don't know how much it's growing by because it's still to the 12th power. So in this step, I'm going to simplify this piece. Well, I go back to my calculator and I can probably take this base and just use the exponent button, which is this. And it did a little thing there. And I bet now I'm writing the exponent 12. That's a beautiful thing, equals. Boom, I got it right here. I'm going to take that, I'm going to go back here, and I'm just going to copy that over this. It's a beautiful thing. Now I want to know what is this rate in annual interest, and if I read the problem, it says round to the nearest thousandth of a percent. Well, I know this beautiful number here in a formula for annual interest represents 1 plus r, 1 plus the rate. So what I want to do is subtract 1 from both sides. When you subtract 1 from both sides, I'll be left with just r here, and I'll be left with a 0 here. And now, of course, this is still a decimal. I want to write this as a percent, so I multiply by 100. That moves the decimal 2 places to the right. I get this. And rounded to the nearest thousandth, the thousandth digit is this 6. Keep it the same because of the 2 that follows. This is 7.656% annual interest. So this is 7.656% annual interest. Very cool. You're going to do the same thing with the rest of the functions there, and you will have converted them all into annual interest rate. Very neat. Cool, cool. So there you have daily, you'll do weekly, and then continuously. Part 3, what it's going to ask you to do is, Serena and Juan want to know how long it will take for their money to double in the bank. choose any bank account to see how long it's going to double. The easiest one to do is going to be annual interest. So I'm going to grab that one. It's the simplest of the formulas and it will be the easiest to create. Well, if I want to see how long it's going to take for their money to double, think about it. They started with $750. How much should be there at the end of time in order for it to double? Well, here there's going to be $1,500. Duh. In order to solve by an exponent, you have to take a logarithm. But we don't want to take the logarithm yet because the base isn't isolated. You have to isolate that base. So what I'll do in the next step is divide both sides by 750. And rather than write it out, I think people know what would happen. Here it's a product, so the 750 would disappear. And here I would get 1,500 divided by 750 is 2. That 2 is not a stranger 2. Everyone's going to get a 2 because the money's going to double. That's where the 2 came from. If it was going to triple, there'd be a 3 there. Quadruple, a 4 there. So everyone's going to get a 2 regardless of how much money you started for. And maybe I'll just simplify this here. Cool. In order to get rid of an exponent, you take a log. Log is the inverse of exponential functions, remembering that log is just an operation, but there's no symbol for it, so we just write the word log. And then there's a beautiful property of log that says if you have an exponent, you're allowed to move that exponent to the front and write it as a product. Well, now you can very easily see I want to get t, or time, by itself. So what should I do? Well, I have to divide both sides by this log here. Divide both sides by this. So maybe I'll be fancy and show that this time. Go like this. Down here, I can show division of that log here. Let's see if I can copy and paste it. Boom. Let's do the same thing over here. I'm going to go like this. Show division. Great. Now that I'm showing division, I'm going to show the division in this step up here where I kind of didn't show the division. I think it's kind of a neat thing to show. So I'm going to go back and be complete. I said I wasn't going to show the division. Guess what? I'm going to show it over here very easily. I could highlight, hit my fraction. I'm dividing both sides by 750. This side here, highlight, hit the fraction, divided by 750. That's a beautiful thing. That's where that came from. Great. What's left here is the right-hand side, you could probably see is going to cancel. The log 1.072 and the log 1.072. I'm just left with t. Here I have something that just goes in the calculator. Log of 2 divided by log of 1.072. Boom. I'm going to clear everything. I'm going to write log 2 divided by, I'll close the parentheses, divided by log of 1.072. That represented my 7.2% interest. I get this fantastic number here. So here, I now know that this, wow, that's a big number. Let's make that a little smaller. Bump down that font size. That's still kind of ridiculous. Here, I don't believe I said what to round to, so let's round to the nearest tenth here. Maybe nearest tenth is fine. Here I have 9.9, and I look to round that 9 based on the 6 that follows. Well, that 6 says round this 9 up to a 10. So this actually rounds off almost perfectly to about 10 years. So 10 equals t, meaning in 10 years, the account will double. We'll have $1,500. Pretty sweet, pretty sweet. So you only have to do one of them here. Annual interest is going to be the simplest one, and that's pretty great. So that would be part 3. Cool. Moving on, we're almost there. It's a beautiful thing. We're moving on to part 4. And part 4 wants to know about torn between which accounts to use, the monthly and the daily. If we go back, we had 2 accounts, monthly and daily. And before I even read the rest of the problem, let's go back and copy those 2 accounts. Here's my monthly account. I'm going to copy this right down here so I have it. Boom, there it is. I'm going to grab my daily account. Well, I kind of didn't finish the daily account, so maybe I'll go up here and finish it. Here's my daily account with E.8%. My daily account is going to be here. Sorry for all the scrolling. My daily account's going to be here. Noisy keyboard with E.8%. I know E is 7, but what did I have for A? I think it was 1. Yep, 7.1%. So let's do this. We're going to be good now. Apologize for all the scrolling. Here my rate is 7.1%. And if I write 7.1% as a decimal, you have to move the decimal 2 places to the right. So that's going to be, if you guess, 0.071, no more percent. There's my daily. So now I have the 2 accounts. I got the daily, got this. It's a beautiful thing. That's a beautiful thing. Great. Fantastic. Let's go back and read the problem. Make it a reasonable 125. Serena and Juan are really torn between using the monthly account. Make a nice blue, or nice blue is nice. My monthly account, which you could have guessed is monthly, it does say MFT, and the daily account. They cannot decide which one to use because they don't know how long they will make the investment for. If they invest H dollars, that's our $750 for F years, into both the monthly and daily account. After F years, which one is better? How much better? Oh, darn. So we want to see for F years. Okay, we can do that. We just need to know what F is. For our problem, I believe that I picked F to be 5. Let's just double check. Here, I picked F to be 5, and G was 25. So I want to know which one's better after 5 years. Okay. Which one's going to be better after 5 years? Well, in order to figure out which one's better after 5 years, I need to just plug in for time 5 years. I'm not crazy about the way that it did that. I kind of want to keep the daily. There we go. So don't do that. Delete here. Great. I'm going to plug in 5 here for T and 5 up here. Okay. So that's like a times 5. I hate using that. I hate using that X there. It looks like a variable. Let's see if they got a beautiful symbol here for like an operation. Ooh, I like that dot. That's ice. And down here, I'm going to do the same thing. Plug in 5 up here. If this one was 12 times 5 as an exponent, this one is going to be 365. Use my little symbol, dot 5, close parentheses, boom, boom, boom. All right. What would be lovely is if I could just copy and paste this into the calculator. I don't think it's going to be so lovely, but I'm going to give it a shot. It is not so lovely. I need to actually type it out, which is annoying. So that's 7.4% compounded like that. Let's try this. I have 750, right? 1 plus 7.4, open parentheses, 1 plus 0.74 divided by 12. Whoops, that's 74% interest. And it won't let me do that, so I gotta go the whole thing. No big deal, divided by 12, boom. If you wanna be super fancy, you could open up parentheses here for your 0.074% divided by 12 to show that that part's together. Close parentheses for the base. Take an exponent, and here it's 12 for monthly times, I'll hit that, 5 years, boom, and I get this much money. Fantastic thing. I'm gonna go down here, and I'm gonna hope that it's not obscenely large. Of course it is. Why wouldn't it be? Why wouldn't it be? Great, and now I'm gonna do the same thing here. What would have been special is if I could have just like edited this, but of course that would just be too simple. So here I had 7.4%, here I have 7.1%. All right, but I still start with the same 750, so let's do it. Here I get 750, open parentheses, 1 plus, open parentheses for that fraction in the base, 0.071 for 7.1% divided by 365 for daily, close parentheses for the entire base, drop the exponent, didn't do it, did it? There's the exponent, open parentheses for the exponent, 365 times 5, boom, equals, okay, copy and paste this, tab, to jump, boom, make that a nice 12, and I want to see which one has more money in the account. According to this, it looks like the first one had more money in the account. Let's start rounding to see. Here I had $1,084.57. If I look at that penny, I need to round it up because of an 8. If I look at the next one, it's $1,000 and $1,069.59 would round up to 60 cents because of that 8. So here I can see the monthly account would have more after 5 years. How much more? Oh, well, now they're being particular. Well, I can just copy those numbers into the calculator. Bada bing, like so. They don't make it easy. They don't make it easy. Well, I'm going to just subtract those numbers. 10084.57 minus 1069.60, and I got $14.90. So the monthly account would have more after 5 years by $14.97. A crazy amount of money? No, $14 is not a lot of money, $14, $15 after 5 years too. But it is more money. So if you did have an option, clearly you're sitting at the bank, they say, which option would you like? You're clearly going to take the one where you make another $15. There's a second part to this question that I'm going to leave up to you, the viewer. In the second part, we just changed the number of years, but it's the same question. So in the first one, we did after 5 years. In the second one, I'm doing whatever my G value was. For me, it ends up being after 25 years. And we're trying to see if the one that was worse can catch up. In this case, I'm guessing it might. Sure, the interest rate is less, but we're compounding it more often. So that's what you're going to find out. And you never know which one is going to be better until you check it. That's kind of the beauty of these things. So with that being said, I'm going to move on to the last step. The last step's my favorite. It says use Desmos.com to graph all 5 functions over a 30-year time period. Use an appropriate window. It's a beautiful thing. I'm going to go to my graphing calculator, and it's a beautiful thing. I'm going to open up this here, and I'm going to start to graph my functions. First thing I'm going to do is I'm going to go over here to settings, and I'm going to change my window. My x-axis, I want to look for 30 years, it said. So I'm going to write -1 so I can see the x-axis, and then I'm going to go up to like 31, and maybe that's probably fine. I like to get rid of the minor grid lines. And then my y-axis, I'm not sure what it's going to be yet, but I'm assuming we're going to have a lot of money if I'm starting with 750. So I'm going to say maybe up to like 10,000. I may adjust that later, and we'll count by like 5,000s. That's a lot. Up to 10,000, my bad. If I go up to 10,000, I should probably count by like maybe 500s. That's not too shabby, and maybe make this like -50. We can adjust it later. But here I have it. You can zoom out a little bit to see it. There it is. Beautiful thing. First function was y equals, or I could be fancy and go a of t equals whatever my principal was, 750. Let's look at that first fantastic function that I created way back when. 1 plus, this was 7.2%. Boom. So I'm going to go 1 plus 0.072 to the t. Beautiful function, annual interest. The next one was my monthly interest, m of t equals, and let's do that one, go back here. What was my monthly? 7.4% compounded monthly, 7.4% compounded monthly, 1 plus 0.074 divided by 12. Desmos is a beautiful thing. Look at that. It kind of writes the fraction the way you would, times 12t. You can see it's increasing a little bit faster. I love how I put in a different color for me immediately. Let's go and look at my next function. My next one was the daily one, which I wrote somewhere down here. Daily was 7.1%. Let's do one more. Do my daily function equals 750 times 1 plus, what do we say, 7.1, so 0.071 divided by 365 for daily to the 365t. It's a beautiful thing. You can see that function. And now that I'm looking at this, I can see how it kind of is working over 30 years. It's kind of a really beautiful thing here. Maybe this is kind of the way I want to look at it. Maybe I'll go back to settings, my x-axis. Sure. I kind of like when I can see a little bit of the negative part. Yeah, so I can see where it goes. The y-axis, maybe I can get away with -1,000. That seems pretty sweet. And counting by 500s, I had it. Maybe I'll change it to counting by 750s. That's kind of cool. And there you have it. So once I want, there's 2 more functions here. Of course, I need the continuous. Of course, I need the weekly. But what I might do is I might go here. You can actually exclude the weekly on this one, but once I have it, I'm going to just screenshot this, Command-Shift-4, and just do a nice, beautiful screenshot of this. That's a beautiful thing. And what I want to do is just go down here, and I want to just copy and paste that here. So I can kind of just go like this, grab that screenshot off my desktop. The image is unformatted. No, it's not. Let's try again. It was a PDF that was unformatted. You were right. There it is. Beautiful thing. Dismiss. And there you have it. You'll have the different ones, right? It'd be great if there's a way to label this stuff. Let's see. Settings. Let's bring this back over. Is there a way to show a label here? Like settings? Like, come on, show a label, would you? I guess what I'm going to want to do is screenshot my functions as well, so that when the reader is looking at it, they can see the names of the functions. So although this graph is cute, I might leave it there because I don't hate it. I would want to put one in here, my screenshot, that has the actual functions there. So there you have it. That was a super duper fast overview of the project, but I wanted to make sure that you could watch this in the time period of like a class period or something, get an idea. Of course, I'm available here on Zoom to answer questions for you after you watch this video, but I hope it helped and I hope you enjoyed watching. Until next time, I'll see you soon. Have a great day. Bye-bye.